Hello, everybody. I hope this is working fine. I think it is. We're going to get started in a minute. I'm going to share my screen again so everybody can see the link for this notebook. We're going to actually, it's on the chat. So I think I'm just going to leave that one there. And we're going to start in just 2 minutes. So people are still joining. Let's give it a second. All right, so I think we are able to start. It's a good time. So everybody's on time, and we have a little bit more time to show what we are supposed to show today. So welcome if you're watching the recording. Welcome too if you're joining late. This is going to be recorded in case you folks need to consult it later. We're going to investigate a couple of very interesting things, and we're going to leave these activity open. Sorry about that. So as I was saying, we are going to leave these activity open. So everybody can start working with it after the workshop. We're going to just do a quick introduction, and everything else going to be left to you. So you can start practicing and you can start working. We're going to work with these managed Jupyter environment that has notebooks that are ready to start right away without the need of installing any libraries. So it's going to be, of course, a lot easier to get started with it. So I'm going to share my screen. I also have, 1 second, because I also have right here access to the chat of these live stream. So if you people if you have any questions, you can always pick them up. So we're gonna get started. I'm gonna share my screen. There you go. And we have a couple of things going on here. First, this is the project that I will be using. As you can see, it's under my profile. You folks will have here, you will see a different button that it's gonna say fork this project instead of open lab. In this case, as it's my project, I will be opening my lab. Once you can fork this project without the need of creating any accounts, or like just you can fork it and start working immediately. No need of email, name, nothing. This is a completely free service. So you can start right away with your work. So that is it. Once you forward this project, and I have, again, you can just use this URL that it's also in the chat. Once you fork this project, you will be dropped in this environment, this lab, which is just a Jupyter Lab environment. And what we will be doing is we will start analyzing. I'm going to introduce the data set that we will be using and also a little bit about this workshop. So to start things off, this workshop is promoted as machine learning or data science for business. Okay, we want to talk real business applications when we are using data science. Usually, data science books, posts, articles, they are usually targeted for more like educational, from an educational perspective, which is fine. But what we will try to do this time is show you a real application of what you can do with data science. And actually, it's just the tip of the iceberg. We're going to leave a couple of topics open because this is actually a very good discussion, something that, you know, it can take a lot of time. So to kick things off, I want to introduce a couple of examples of when these might be helpful for, when data science might be helpful for business. And there are two very good examples that are, to be honest, also very popular. You might have heard about them. And it's going to let us understand when data science can be useful for business and how. What are those key points that are going to let us improve in our business or get some competitive advantage, etc. So the first case, and this is all again in the notebook, you can, the links are here if you want to read in more detail what we have, etc. In the first case, I'm just gonna tell you like an overview. It's a very interesting case of 2004. It's a long time ago, when the Hurricane Francis was striking close to Florida. So the Walmart board, if you want, they needed to stock those stores, right, with the appropriate items. So what should we bring to a Walmart store in a city that is about to get hit by a hurricane? So of course we have the usuals, you know, batteries, water, double T, flashlights, etc. By the way, this is all marked down. You can also modify it. I can even fix this right here. So water, flashlights, all those things that you folks could be, you know, needing if a big storm is about to strike, especially, you know, power going out, etc. But aside from that, what else? It's, you know, it's like Walmart had a lot of data at that moment. Reportedly, they have 460 terabytes of data, and this is 2004. Oh, sorry. There's a lot of data, to be honest. So they decided that they could take a peek at that data and somehow get a better understanding of what their customers might be needing. Okay. So they did a little bit of data mining, and they found that there were two items in particular that seemed to be in more demand in other places across the country when a big storm was coming. And they were very funny, but one of them was strawberry Pop-Tarts, and the other was beer. So they actually brought a lot more items to those stores of both Pop-Tarts and beer. And it actually proved to be correct. It was the correct decision to overstock, if you want, those stores with these two items. So the full story is right here linked. You can see it. And this is the first important scenario for data science and business, right? It's making better decisions, supporting decision making. Usually, decision making is something of a human's terrain, right? Something that we as humans will be making, and usually we use our own intuition, right? It can be biased to make those decisions. So this is the first important application of data science for business, helping us make smarter decisions, finding these patterns that people at Walmart might have never realized that these two items, strawberry Pop-Tarts at least, were important to bring during a storm, right? So again, supporting decision making, finding patterns we might have not found in other ways, and also giving us data, right, to support those decisions, to have a better routing on them, and sometimes even discard some decisions that we might have taken as humans because they are not supported by data. The other very interesting story is the one of Target, that using a predictive model, they could identify when a woman was pregnant, and also they could predict the stage of that pregnancy, 5 months, 6 months, etc. It was a pretty interesting case when it came out. It's actually a little bit, of course, I don't know, it's on the edge of privacy. But a Target did it, and they were using a prediction model to offer these women coupons and offers based on their needs. So again, these two pieces are all linked in the chat. I'm gonna wait a second in case you folks need to ask anything. We're gonna be consulting that. And there is a big difference here in terms of decision making, and this is the second important application of data science and business. And it's also kind of relative to the time these two events happen. The case of Target is actually set in the year 2012, and there is a very important component to it, which is the real time decision making. Okay, in the case of Walmart, they took some time, right, to dig into that data and make the decision, probably supported by humans, right, with experience, the board of directors, or not the board of directors, but someone with a little bit more expertise, right, where they were looking into these facts or pieces of data and understand what they had to do. So this is a more offline process. They sat, dig the data, analyze it, and they came up with the decision. Now, in the Target one, this is a more real-time event. Okay, they are classifying women in real time and offering coupons or just different, for example, I don't know, sales prices or just coupons for those women that they detect pregnant, and also given the stage of that pregnancy. So there is a big difference here, and it's that a computer can act a lot quicker than a human being. Okay, so this is the big important difference between these two. And the second important takeaway of business and data science: using data science techniques, you can act a lot quicker. You can anticipate many things and gain a competitive advantage. So to introduce today's topic, I want to show you the data set we will be working on, which is it's a data set that contains customer churn. Okay, churn is defined as a customer that is leaving our product or a subscription for any reason. Usually, we say they are leaving for another service, for just a competitor, right? So in this case, that's why we have this funny picture here. But again, it's a customer that it's leaving us. We are losing that customer, and it's something, of course, that we want to prevent. And again, this is customer churn. This is the original data set we have pulled. You have the source here in case you want to read a little bit more about it. It's actually from the IBM website, so you can check it out. We've done a little bit of both cleaning in Notebook 1 and data analysis on Notebook 2, just very likely because, to be honest, the data set was very clean already. I will not get into it in terms of code, but I want to show you some of the findings that we did, again, in just a very quick data analysis process, exploratory analysis process, because, again, the idea of this workshop is to focus on the machine learning part. So these are kind of the columns, right? The features, the characteristics of each one of these customers. So these are each one of these is the ID of the customer, and then we have a couple of important features, right? So for example, this customer is female, is not senior citizen, is a partner, has no dependents. Tenure is just one period. We don't know how tenure is expressed, probably months. So it's the period, the tenure here again is just one period. If she has phone service, she doesn't have phone, and she does have internet service, which is DSL. Does she have online security, online backup, or device protection? These are multiple plans, right, or different products that this company is offering on top of the internet service. Something that I didn't say, sorry, I should have started with that, is that this is all for a telecommunications company. So think AT&T, T-Mobile, one of these are the customers that we are analyzing. So again, these three features: online security, backup, or device protection. If they are asking for tech support, if they have subscribed for streaming TV or movies, the type of contract, okay, month to month, 1 year, 2 year. There's actually 2 year. If they have signed up for the paperless billing, the payment method they have decided, electronic check, mail check, etc. Monthly charges and total charges. So this is just, to be honest, this is a monthly fee that we're charging them, and it's just total charges is a multiplication of the monthly fee times the tenure, right? Again, we don't know the periods, probably monthly. We can simplify it with monthly. And finally, to wrap it up, we have the final value or the final variable that says if this is a case of churn, if this customer has left our service for a competitor. In this case, she has not. She's a loyal customer, so she has still our service. So doing a little bit of exploratory data analysis, you're going to find something at the beginning is that these data set is really unbalanced. That means that there are a lot less customers that have churning through, that they have left. Okay, so there is the common case is that the churn is false. How can we find we can quickly also see the distribution of these periods in terms of time. So you can see that there are a lot of customers at the beginning, right, that they are just probably just trying out the service. And then we have a lot of customers that stay loyal after 60 or more periods, right? So this bimodality, right, something that's going to be interesting later. How is churn affected by tenure, right? What's the distribution of those customers that are both active and inactive? So we're going to see something in dark blue. We're going to find those inactive customers, those customers that have left, all right? Churn equals true. It seems like people are going to leave. When they leave, they're going to leave pretty early on the service. Okay, so this is a very important takeaway. If we could measure the area under this curve, we're going to find that most people, actually we could run a simple statistic to find that most people will leave before their 20th period. Okay, so if there is a very important moment in which we should retain and we should take action to retain a customer, is before that 20th period. Okay, under that curve, there's going to be the highest concentration of churned customers. For those active, we do see kind of a flat, right, uniform distribution. Everybody just staying there. This is the same thing expressed as bars. Okay, so this is just a distribution plot simulating a continuous probabilistic variable. In this case, just the real data. So we find that most people, right, will leave again in their first period, second period, and again, just we said the 20th. That's around here, right? Everybody is living there. We could also focus on the relationship between some of these variables. So for example, how is tenure affected by total charges? Something kind of obvious, right? Because at the more time they're spending with our service, the more we're going to charge them. So again, it's kind of obvious. One problem we have with these data set is that we don't have a lot of numeric variables. It's just mostly these categorical ones like are these customers partners? Do they have dependents? Do they have phone service? Yes, no. What type of multiple lines they have, etc. What time of internet service they have. So in that case, it's a little bit more difficult to do these sort of analysis, at least correlation analysis. But some other things we found, again, really quickly doing some exploratory data analysis, is that, for example, if we could divide the type of internet service that the customers are using, we see that the highest churn is found on those customers that have fiber optic. So those customers with fiber, I'm going to say, tend to leave our service. So it's a higher probability, if you want, that the customer is going to leave for fiber. So here it's when the business comes into play. It's like you have to start analyzing, why is that? Maybe we have very good competitors in that space. Maybe we are not very good at fiber optics. So maybe we have to check again why fiber customers are leaving. Okay, so this is a very important characteristic. You can actually plot these categorical variable with a little bit of both charges and tenure. It's not going to tell you much, but it's just that. And then from people that are living and staying, we have separated them into different categories. So for example, people with only online backup, or only online security, or only, where is it? Device protection, right here. And we see that everything is pretty stable, unless two important things. People that have no services will tend to drop more. Remember that by itself, this is a highly unbalanced data set. So a lot of churn above the no churn is even worse than if they would be, of course, balanced. So in this case, again, we see that if someone doesn't get multiple services from us, from our company, they will tend to leave early, and that they will be accounted as churn. So it's like we, of course, have to generate some sort of dependency to our services, because actually those customers that have 3 services, that have backups, device protection, and line security, they tend to stay loyal the longer. So they have probably just found, right? We've just found a protection against these customers leaving. Okay, we have put a higher barrier if they want to leave. Okay, so this is just, again, a little bit of analysis of our data set. We were going to see if the machine learning part of it, right, has some correspondence with our previous analysis. All right, checking questions. Let me go. And moving forward, now that we have analyzed our data, we're going to start doing some machine learning. But it's not going to be used to just jump ahead and predict if a customer is going to leave or not. That is, of course, the final result, what we want to finally predict. We want to be able to, as Target did, right, predict kind of in real time if a customer is going to leave our service, and in that case, or cancel their subscription. And in that case, maybe offer some special just offers, or I don't know, promotions or coupons or benefits, etc. But now what we will be doing is we will be using machine learning, one very simple algorithm of machine learning as support for our analysis. So I don't want you folks to focus so much in the predictions that we will be making, but we want you to see the process we follow. So first of all, our data set has changed a little bit because we have cleaned it. Remember, we have this clean phase, and we will actually change it a little bit more here. So the first thing we're gonna do is, and this is an important concept for all of you, is that all machine learning models, they need to operate on numeric features. Okay, so these are going to be the features of our machine learning model. We're going to tell about a customer that she has this type of contract, that she has indeed signed for paperless billing. She has this payment method associated with her account. So we will be telling to the machine learning model these features, and the machine learning model will be able to predict these outcome or response or target. It has multiple names, so we can call it just outcome or response variable. The important part here is that both the features and the response should be numeric. A machine learning model cannot work with something like the payment method of this customer is electronic check. Or for example, right here, is this customer a partner? Yes or no? That's something that a machine learning model can't use. They can only use numeric features. So what we will be able to use are here ones and zeros, right? So it's very obvious that here we can just do 1, 0, and keep all the yes in ones and all the no's in zeros. So that is exactly what we're doing here, right? We're fixing a little bit of data frame. So now partner becomes 1 and 0, phone service becomes 0 and 1, 0 and 0 for multiple lines. So far so good. That's the change we've made. The same thing, sorry, for online security, online backup, device protection, tech support. Everything that was a yes is gonna be 1. Everything that was no is gonna be 0, and the same for these two examples. Okay, so the first thing we're going to use is also start making a little bit more cleaning tailored for the machine learning part. So this is important. Usually, for example, in our data analysis notebook, we did a very simple cleaning process because we just needed to identify issues with the data set, dirty values, right? Like just invalid values, etc. And then that was it. It was enough to do our data analysis. For machine learning, you usually need to do an extra set of cleaning, if you want, or wrangling of your data in order for it to be ready for your machine learning algorithms. And the first thing we're going to do is we have to first change these variables to numeric. Okay, so how are we going to turn these variables into numeric? They are strings. So what we will be doing is turn them into dummies. Okay, and I'm going to show you an example really quickly here with internet service. We said there are two types of services, either DSL or fiber optic, or no service at all. And what we want to do is we want to turn this thing into a numeric variable. What we're going to do is introduce the concept of a dummy variable. Instead of having just one column that says internet service, DSL, internet service, fiber optic, internet service, no internet, but I have 3 variables now, 3 different columns that pretty much says, is internet service DSL? Yes. And of course, then we have fiber and no internet service, and these are empty. So the combination of these 3, for each combination, there can be only one number 1, and the rest are going to be zeros. They are like flags that are set for that given value that we have. So this is an important concept. So the first thing we're going to do is introduce a decision tree, okay, which is a very simple machine learning model. And what it will do is actually, let me just show you what it's going to do first. I need to install this library. and probably this library. This is what a decision tree will do. Okay, it's a very simple model, and what it can do is just give you those. What a decision tree will try to do is creating a set of a tree, plain and simple, with multiple decisions for each one of those leaves, or actually those joints, because we will actually have more levels, in which a decision should be made given a certain variable. In this case, this is a highly unbalanced tree, so it seems like it's always predicting no churn. Don't worry about that yet. But one important feature that our decision tree is finding is that the contract month to month type will have probably a higher probability to be in the churn set. And this, of course, makes sense. A person, a customer that it's bound to a 1 year or 2 year contract will probably not leave. Okay, someone that is in the month to month is more likely to leave the company. So again, this is kind of obvious given the simple data set we have. But again, a decision tree is very quickly telling you which variables are important. What I've done here is just limited this decision tree to only have one level, so that's the maximum depth. But we will actually start giving that decision tree more levels. So in this case, what I have is a one-level decision tree, but I have made it a balanced one. I know that internally my data set is unbalanced, so I want to fix that. And if I do that, the predictions are going to be different. I can then move to a two-level decision tree. And here we're going to find what is that second variable that it's going to be important. And here, remember, related to our analysis, we found that our fiber optic characteristic was very important in order to predict churn. And it's something that the decision tree is confirming. Okay, if fiber optic is greater than something, that's going to be it's going to be make more likely, if you want, that the customer is going to leave. So again, this decision tree is not used by itself given to predict things. Actually, if you check the score, it's only 0.75. The data set by itself is highly imbalanced. So this is actually a very bad score. We're going to see why later. It's not that important to make it, in this case, predict things, but understanding what are the variables that the decision tree is using to make those predictions. So what are those variables are tilting, right, the decision? Okay, again, month to month and fiber optic, it actually seems to match our analysis. You can make this tree grow as many levels as you want, and then you're gonna see later that things like the tenure are gonna be important. So remember, we actually said that the tenure is gonna make, if someone is in these ranges of very few months, or even these not so many few, but still less than 20, we're gonna find more churn in these. So again, a decision tree is usually not used to predict things. It's actually has the limitation that it's gonna be overfitting things. All right, it's an overfitting, has this tendency of overfitting, but it's very good to have a good understanding of what are those important variables when we need to predict the outcome of a user. So now that we have given a little bit more context to it, we want to see what other machine learning models we're going to use. And in this notebook, we're going to introduce logistic regression. We're going to introduce support vector machines. We're going to introduce neural networks, and also multi-layer perceptrons, which are just, well, actually, I said neural networks. We're going to introduce neurons or perceptrons by itself, just one, and also an ensemble of multiple neural networks that is usually called a multi-layer perceptron. So to get started, we have pretty much the same thing as before. We are reading the data set that we have kind of committed, fixed or saved in a previous step, that it's clean and the information is organized only with numeric variables as we know it. And now we are going to use it to predict multiple values. The first thing we're going to do is scale our variables. Something that some machine learning models will have problems with is with unscaled data. So a machine learning model will see something like 0, 1, then it's going to see something like 45, then it's going to see something like 40, 53, and you can even have smaller numbers like 0.3, 0.003. So having variables that by themselves, they have very dissimilar units is going to be problematic for machine learning. Usually we want the units, right, or these numbers to have a similar range, if you want. To do that, we will usually scale the data. We're taking a very simplistic approach here, and there are actually multiple methods in, for example, scikit-learn to scale the data. You can check the standard scaler. Also for normalization is also important. In this case, we're just doing the standard scaling of the data, which is just subtract the mean and divide by the standard deviation. We're gonna see that so for example, the mean of something, let me actually read this thing again, df at tenure.mean, we rate that is 32, right? So the standard deviation is D, 24. So these one, right, subtracted by the mean, and then divided the standard deviation is going to give you minus 1.27. So that value that was 1 before now becomes minus 1.27. So scaling for both tenure and monthly charges, now we're going to see that they are both with the same scale, right? 1.27 and monthly charges is 1.16, even though originally they did have very dissimilar units. 245 and monthly charges were 5342, very dissimilar units. We're going to export it in case we need it later. And now what we're going to do is start the prediction with multiple machine learning models. The first thing we're going to do is split our data, something that we have done previously in our previous notebook, but I on purpose skipped. In this case, we want to divide our data set in two big parts. One is going to be used for training our machine learning model, and the other one is going to be used to test it, to validate it, and to see how good, if you want, that model is performing. Okay, so it's like you're gonna train with this data set, with this small subset of the data, and then what you're gonna do is let's actually test it against some data that it has never seen, and we can have some better understanding of the validation. The first machine learning model we're gonna see is logistic regression. It's a very simple machine learning model. It's actually probably the standard in educational resources for classification. It's a very simple one. And the way to use it, it's going to be as usual, all with scikit-learn, they all have a very similar API. In this case, we're creating the model and then we're just training it. We're training the machine learning process with this .fit method. So I'm going to invoke it. It's going to take a couple of seconds and it's going to spit out that the model has been trained. So again, take a look at what we're fitting it. We're passing to the train method both the features and the target of the train subset, this one right here. So we're basically saying this customer has these variables and this is the outcome. Churn, yes, no, true, false. So now we can quickly predict the outcome of that. So now we can start doing predictions and we can see that our logistic regression is throwing 0.A0 as a score. Is this good? Is this bad? That's a completely different discussion to have. So far, it's fairly good. We will, of course, try to improve it later. What is this right here? This is a very important concept, especially in business and also for medical records and just many disciplines. That it's that a classification method, in this case, again, we're trying to classify a customer and we're gonna understand if that customer is likely to leave our service or not. One important characteristic of these model is not just understanding how good how accurate the model is, also understanding when it's missing the answers. And for that, we're going to use this confusion matrix. This confusion matrix basically is very simple to read. You have these are the true labels. So you know that these are the customers that had no churn. We know it for a fact that they had no churn. But we then predicted no churn. This is very good. And the percentage was 0.89. So 0.89 of all the ones we predicted that had that were not going to churn or leave, sorry, were the case. So this is good. But also we see that we predicted 0.11 incorrectly. That we said, hey, this customer is going to leave. This is our prediction. But then the customer didn't leave. Okay, so in that case, this is what we call a false positive. Okay, it's again, we predicted, hey, wait, be aware, this client is going to leave, and then they ended up staying. Okay, in the other sector, we have churn, so we know for a fact that they left. And the ones that we predicted that were gonna leave are only 0.60. This is, I don't know if it's good, it's bad, we did it well here, but then we have a very high number here because we predicted that they were not going to leave, but they ended up living. And this is a very dangerous metric, sorry. This is what we call a false negative or error type 2. This is very dangerous because we were predicting that they were not going to leave, but they left anyways. So we could have done something if our model worked better. So in this example of classification in which we are trying to make a decision based on that, on a given characteristic, these false negatives are going to be very, very important. And we're going to talk about those in a second again. So another model we can train, and what we're showing you here is we don't want you folks to be experts on just every machine learning model you can. It's just for you as a way to see how they work. It's a support vector machine. It actually took a couple of minutes, seconds, but the score is even less. And we see a very worrying number right here. So this is a support vector machine. Now, random forest. A random forest is what we call an ensemble model that combines, in this case, multiple decision trees. We see also a kind of a bad score, and we also see, again, a high number of false negatives. We're going to use now a multi-layer perceptron, that it's a neural network, plain and simple. If you folks have been working with neural networks before, you will identify things like the activation function we're using, in this case, ReLU, rectifier linear unit, the alpha, right? Batch size, the learning rate, right? All those things are important characteristics of a multi-layer perceptron model. The multi-layer perceptron model is a little bit better, but we're still having this big issue here with these false negatives. So let's take a second look at this problem and see how we can fix it. The first thing we're going to show you is a ROC diagram. Okay, this diagram, and I'm going to open up this link next to it, pretty much showcases how good your model is, but it's not something that it's so intuitive to read, to be honest. Basically, this diagram is going to give you a sense of how many, this is the false positive rate and the true positive rate. How many of those false positives and true relatives are going to happen given, and this is the most important thing of this diagram, the threshold that you are considering for your neural network. Or in this case, sorry, not neural network, any machine learning model. So what you're going to find is that given a machine learning model is like a neuron, right, that acts with an input and with an output. Whenever you're going to feed it a couple of inputs. So for example, is the customer a partner? Yes. Does the customer has internet service? No or yes. Do they have phone? No. Leave to here. Partner. Do they have online security? Yes. Do they have online backups? No. So these are the input of your machine learning model. This input is then processed by the machine learning model itself, right? Model. And it's going to give you an output. This output is a number between 0 and 1. So for example, 0.99. This is, of course, very likely that churn is going to be true. Very likely that they will be leaving our service. What about 0.01? So what's the probability of this customer leaving the service? It's very low. So we can pretty much rule them as they will not leave. So any machine learning model will need a cutoff value or a threshold to apply so it can give you a more meaningful prediction. Usually we use 0.5. So if the customer is if the predicted number is above 0.5, for example 0.51, we're going to predict that they will be leaving. Churn is going to be true. If this is below 0.49, below 0.5, in this case 449, we're going to predict that it's actually 0. So as you can see, it's a very arbitrary number. Just if above 0.5, it's 1. If it's below, it's going to be 0.49. So it's actually something we can work with. What this diagram is showing you is how the threshold of a different threshold, like for example, 0.1, 0.2, 0.3 is going to affect your predictions. The most important things here are both the curves and the area under the curve. A very bad model, a very bad model, is going to be sitting straight in this diagonal. But to show you a little bit more intuition about that, we will be talking in detail about this threshold, that it's something extremely important, especially in business when you need to make decisions. And it's the following: understanding the both types of errors that you can have. So remember these confusion matrix we did. It is somewhere. Did I remove it? No, it's right here. Given this confusion matrix that we used, right here, we had two different types of errors. A false positive and a false negative. Now, what is going to happen here is that not both these errors are the same. Like sometimes it's better to have more false positives. So this is a very good example. A false positive is when it's a false alarm. It's like you're reacting to something even though that is not the case. So for example, in this case, a doctor is telling his patient that he's pregnant. This is a false positive. You're pregnant. Just let's be very cautious here, and let's assume you're pregnant so you can do all the checks. You're gonna lose a little bit of time and money, but it's preferred to make a false positive than a false negative. A false negative, it's gonna tell a woman that she's not pregnant, even though she is actually pregnant. So this is usually the worst type of error, the one that is hiding important decisions to make. Okay, so this woman might not do the required studies and prepare for pregnancy, even though she is, because we had a type 2 error. So this is a very important thing to consider. So can we actually tune this threshold so we can say, actually, let's be cautious? Because if I find that a customer, for example, has 0.3 probability of leaving, I want to take action on him because it's very expensive for me to get a new customer. Acquisition is very expensive. Once they leave, I cannot get them anymore. I prefer to have a false positive, this case, and for example, send them an offer and avoid losing many false negative cases. So all that I've said is all coded here. You can check it out later. But basically, we have, sorry. There you go. It's all here. I'm just executing it quickly. We're going to create this plot. And this is the threshold. Again, if you are very cautious and you say, for example, if the likely of my customer leaving is 0.3, I want to classify them as churn. Okay, I want to change this threshold that it's here, this picture. I want to change this threshold. So if the customer is above 0.3, I am like lowering the threshold. I'm being even more cautious. If the customer is 0.3, then I'm going to classify them as leaving, as churn. So I can, again, react on these false positives. I prefer that instead of false negatives. So these are the three different curves you have changing your threshold. The overall score, you will find the overall score is the best one is probably here in 0.6 or 0.5. And then you have the false positives in green and false negatives in red. And false negatives are going to be very important because, again, we want to keep these false positives low. So we see that having probably a value of 0.3 gives us the best balance between false negatives and a good prediction score. Okay, so let's move forward. And we are going to now check how a deep learning model is going to affect all this. You're going to find that a deep learning model usually requires a little bit of tuning. So it's not something we're going to find or get to right now, but still, we want to show it to you how it will work. So here you go. We're going to use Keras. Keras is a very nice library that works on top of multiple frameworks. The most common and popular one is TensorFlow, the Google one. And Keras has a very simple API to create these deep learning models. And it starts, in this case, with probably the simplest one, that it's a sequential model. And then we will be adding different layers of neurons to our model. Okay, so this is something you can check pretty much in any deep learning resource. Each one of these layers is going to have a number of neurons, in this case 10, and it's also going to have an activation function you can change and tune. In this case, it's a hyperbolic tangent. You don't need to know about the internals. You can also use ReLU, rectifier linear unit. You can use sigmoid. You can use multiple ones. I will also, in this case, have a different one for the output layer, which is the softmax activation function. So I'm going to create my model, and I am going to compile it using this optimizer and using this loss. Finally, I want to keep track of this metric, the accuracy. And this is the model that I have just created. The model is there, like waiting. It hasn't been trained yet. It's like I have just compiled it and it's waiting. So now I'm gonna train it. I'm actually gonna train my model a given number of epochs, 20, and with this given batch size, in this case 32. I'm also passing validation data, the data that I know is correct, but the model will not use for training. It will only use it for validation. So the training is happening right there, as you can see it, just training live. We can see loss decreasing. We can see the accuracy improving, but we're still pretty low in 0.801. Let me show you a couple of values here. We don't need this. And these are the values that we're gonna find. In this case, what we have is just how the model will evolve with the change of both number of epochs for both the training and the validation sets. Okay, so when we increase the number of training epochs, we will change the accuracy of the model. This is something that we have to always, okay, check with the overfitting capabilities of it. Finally, I have another chart that is also showing the accuracy. In this case was loss. In this case, it's going to be the accuracy. So I'm going to give it just 1 minute and we're going to check the questions that you folks might have. And I'm also going to give you a very important, let me see if we have any questions. And I'm also going to give you a very important discount code for our next data science course. Is this code right here. Use this code if you want to join our next data science course, right there. And in the meantime, I'm going to check if we have some questions. There you go. We don't have any questions. So I hope you have enjoyed these. I'm gonna show you really quickly our course. If you are interested in doing live data science course using machine learning, using Python, pandas, check out our course. We have live classes. Okay, so it's pretty much one of these, a little bit more condensed with a little bit more information. So check it out. Okay, we are starting next Monday. So hopefully we'll see you there. You can try the first week of the course for free, just in case. Use this coupon for a 10% discount. Thank you, everybody. I'm gonna stop sharing. Thank you, everybody, for joining. And again, hopefully we are gonna see you all next Monday. Have a great night, and thank you for joining us.